Hi, we're finishing up section 2.1. I did want to bring this section by itself on piecewise functions. This tends to be a topic that really confuses students. These piecewise functions are complicated, sometimes messy, but you just have to take a break and kind of look at the big picture and kind of break it down into its pieces. A piecewise function, first of all, it is a function. So it's got this name, we're going to call this one f, and it does act on some variable. And the reason it's called a piecewise function is because it has more than one set of rules. So for example, this one might say that I'm going to take on the value of x, and then it gives a qualifier. So when we use that piece of the function, we're going to take on this value, so whatever 3x minus 2 is, if x is between 0 and, let's say, 2. And then we're going to take on this value if we are bigger than or equal to 2. Now, first thing we want to note is these conditions that are here should not overlap. So if you are writing a piecewise function, should not overlap. Because the reader needs to know exactly which piece of the function are we going to work with. So if I had an equal to sign here, I need to make sure that if someone wanted to calculate what f of 0 was, that it knows exactly which part to work with. So when you're writing these pieces will not, should not, cannot overlap. So how do we work with these? Well, if I'm creating and I want to find out what f of negative 2 is, the first thing I have to do is find out which qualifier does this value fall into. So negative 2, and it will only fall into one of those pieces. So negative 2 falls into this top one because negative 2 is less than 0, which means this is the rule that we're going to work with. So putting the negative 2 into that top piece, I find that f of negative 2 is simply negative 2. If I wanted to know what f of negative 5 was, again, negative 5, I'm going to decide which piece. Again, that's the first one. So that value is just simply itself. F of 0, so here's where I said we have to be able to determine which piece we go to. F of 0, since 0 is equal to 0, I am on this piece here. So that means I'm going to use this rule. So I get f of 0 is 0. If I wanted f of 0.5, because we could do fractions, there's nothing to saying we can't do a fraction. F of 0.5 falls into somewhere between 0 and 2. So I'm going to have that 3 times my 0.5 minus 2. Okay, 3 times 0.5 is 1.5, so subtracting 2 is a negative 0.5. Or I could have worked with fractions, whichever is easier. Let's do f of 1. F of 1, again, 1 tells me to go into, 1 is between 0 and 2. So that tells me I'm going to go into that piece there. So 3 times my 1 minus my 2. 3 minus 2 is 1. What if I wanted f of 1.5? 1.5 is still in that middle. So 3 times my 1.5 minus 2. 3 times 1.5 is 4.5 minus 2 is 2.5. Let's go to f of 2. F of 2, well, that is this section here now, because 2 is equal to 2, so I now have to bump up to this third set of rules. So I will be doing that 2 squared plus 1. 2 squared is 4, times 4 is 16, plus 1, 17. And I'll do one more. F of 5, again, 5 is bigger than 2. So 5 squared plus 1. Okay, 5 squared is 25 times 4 is 100 plus 1 is 101. 101. Okay, so there's how piecewise functions work. And we will, in the next section, talk about how to graph these, or how to, from a graph, create the equations. So, but I wanted to spend a little bit of time, wanted to break this down really slowly. A piecewise function, piecewise, defined in pieces. This tells us where the rule takes place, and these are simply the rules. So we're going to take these parts and work with them. Okay, I hope this helped a little bit by going really slowly through these piecewise functions to help you. But again, we will be spending more time with them as we grow through the course, as we get more and more sophisticated functions that we can deal with.